order to three force members to be in equilibrium condition, right? Resultant of the force should be zero, right? So resultant of the force should be zero. So similar case like that in the two force member. So sigma of forces should be equal to 0, and the line of action of the forces intersect at a point, right? So this is a special condition for three force members. If the line of action of all the forces intersect at a point, right? So this is that main thing, a point, that is one point, then only the body will be in the equilibrium, right? So if you see F1 is going through this point O, right? F2 is going through this point O, F3 is going through this point O. So all three forces are passing through this particular point, right? So in this case, if the equilibrium, or if the all three resultant of the forces would be 0, then the body will be in equilibrium, right? So sigma F should be 0. All the line of action should pass through one particular point, right? So if you see here, this is the action of the force, okay? A is the action of the point force F1, right? Point A. And point B is where the force F2 is acting. And C is where the force F3 is acting. So they are acting in somewhere here, here, and here, right? So that's why it's mentioned line of action of the forces, right? Line of action of the forces. So if the force is acting here, if we need, we can extend the force either that way or this way, right? This is the line of action of that force, right? Line of action of that force. So if the force F2 is acting in this particular point, we can extend it either that way or this way. Similarly, if the F3 is acting in this point, we can extend it this way or this way. So once you extend, you will find, okay, fine, these three forces are meeting in a particular point, right? So in such case, the object will be in the equilibrium. What will happen in this case, right? So if one is acting in the point A, right, I will take this point as A. F2 is acting in this point, so I will take that point as B, right? And F3 is acting in this point, and I will take this point as C. Okay. So now tell me whether this will be in equilibrium or not equilibrium. Three forces are not intersecting at a particular point. So if you see F2, if I draw, it is going like this. F1, if I draw, it is going like this. F3, if I draw, it is going like this. So F1 and F3 are intersecting at this point. F2 and F1, they are intersecting at this point. F3 and F2, they are intersecting at this point, right? But all three are not intersecting at any point, right? So this will not be in the equilibrium stage, right? So whatever the force is great, then that will start moving in that direction, right? So we can draw these three forces in a triangle, right? So this is what we call it as force triangle, right? So F1, so this is what you have done like in the velocity triangle and acceleration triangle, right? So we are moving the force. So this is the F1 force. We are moving it parallelly, right? So this is our F1. And then we have the F2. So I'm moving it somewhere here. So that is F2. So this triangle, the sides need to be drawn according to the scale, okay? So similar to velocity triangle, velocity triangle, yes. And this F3, it is going on upwards direction. So I will do like this, right? So F1 is acting in this way, F2 is acting in this way, F3 is acting in this way, right? So if you want to check whether these 3 points are meeting at a particular point, either you can extend the lines and check, or else you can draw them in a triangle and see whether it is forming a complete triangle, right? Complete triangle, right? So this is also a way we can just check. I will draw just 3 forces here. Can you guys tell me whether, so I am talking about this slide, okay? This particular slide is there. We assume this as an object. So I am saying I am applying 3 forces. So this is my F1, this is my F2, and I will draw one more F3. So can you tell me whether this slide will now be in equilibrium or not? Here I have the line of action of this force, right? That is F1, and this way I have the line of action of the other force, right, which is F3, and here is the F2, right? So they are not meeting at a point, right? So in this case it will not create a equilibrium position. Okay, I have a force like this, right? F1, another force like this, F2, right? F1 and F2 are parallel, okay? F1 and F2 are parallel. And I have another force F3, right? So this is F3. So in this case, it will form a equilibrium or not. So these 3 forces are parallel to each other, huh? So they will act like this. So if this condition is fulfilled, right? If F1 plus F2 is equal to F3, then only this system will be in equilibrium, right? So this is the only special case in the 3-member forces, right? So this will act in equilibrium if this condition is fulfilled. If this condition is not fulfilled, then this will not act in the equilibrium. So these are the 2 conditions for the equilibrium of 3 force members, right? So resultant force should be 0 and the line of action should be meeting at a point, either this, or the resultant should be 0 and all those 3 forces must be in parallel, but one should be opposite to other 2, right? One should be opposite to other 2, right? So this is a special case, right? Member with 2 forces and a toe, right, for the equilibrium. So now we are getting little by little into complex things, right? Member with 2 forces and a toe. So if you see, this is a system, right? So if you assume we have this 4-bar mechanism, right? So if we remove all those bars and if you allow only 1 bar, this is how it will look like, right? Here is a joint. This one is a joint, but it is not attached with the other member. So we actually remove that member in order to make the diagram simple, right? And if we are applying some force, I mean a toe, then it will tend to move, right? So this is a simple system. So how is this system going to be in equilibrium? So now that's the concern, right? Forces are equal in magnitude, parallel in direction, and opposite in sense. Forces are equal in magnitude. So F1 should be equal to F2, right? Condition. Forces are equal in magnitude. Parallel in direction. So this one should be parallel to this one. If you see, you can simply say this and this are parallel in direction. So equal in magnitude, parallel in direction, and opposite in sense. So this is acting this way and this is acting this way, right? Opposite in sense. So this is one condition, right? Now then, forces form a couple which is equal to opposite to applied toe, right? So if I am applying a toe in this clockwise direction, right? So there's a toe. right? This is a toe applied in clockwise direction, right? These two forces, which two forces? This F1 I will draw separately, and F2, which are acting on this body. I told you they will form a couple, right? So if there are two forces acting, then definitely they will form a couple. So we'll take a particular point and we can take the moment, right? So in this case, either I will take this point to take the moment, or I will take this point to take the moment, or I will take this point to take the moment, or I will take somewhere here a point for the moment. So I will make that as A, this point as B, this point as C, and this point as D, right? So in order to take the moment, which point do you think easy? So with any point I can make the moment. Which point do you think easy? So if I say which point I would select, I would suggest D. Doesn't matter, you can go for B or C or A, anything will work, right? Only thing is easiness, I told you now. So which point we are selecting would be the easiness, right? So in this particular case, right, in this particular diagram, either B or D would be fine. It will not make any difference. But, right, but if I have another joint here, right, if I am determining something in this joint, right, there is an F3, I will say, and if it is F4 here, and I have a B and I have an E, right? In this case, right, in this case, I would say that I will select B point, right? In particular this case, because this joint will also move, right? So while solving this equation, you need to separate this joint and this joint, right? Selecting B or D will not make any change, right? So either I can go for B or I can go for D. Both will have same impact. So I will select now any one of these. So the distance is H. So if I take this point, right, so what we have is in a clockwise direction, I have F1 into H, right? In the anti-clockwise direction, there is an F2, but since I am taking this point as the reference point, then there is no distance, so that is equal to 0. So clockwise direction, F1 into H is equal to F2 into something, that is 0. So I have a toe also, right? So this toe is coming into action, right? So that is also appearing in the same direction, clockwise direction. So I will put plus toe equal 0, right? So in this case, I'm talking about the second sentence, right? Forces from a couple, so this is that couple F1 and F2, right, which is equal and opposite to applied toe. Equal and opposite to applied toe. So applied toe is the T here, right? So T in the clockwise direction is the applied toe, right? So T is the toe. So what our couple, that is F1 into H, is the couple we derived, right? It should equal, so this toe should be equal and opposite in direction. So if this is going in the clockwise direction, this should go in the anti-clockwise direction, right? If toe is going in the clockwise direction, our couple should go in the opposite direction. So that's what meant by this sentence. Forces form a couple, right? Form a couple which is equal, right? So equal in the sense toe should be equal to F into H, and opposite. So if this is going in the clockwise direction, this should be going the anti-clockwise direction. to the applied toe. If these two sentences fulfilled, then a member with two forces and a toe will be in equilibrium. So this is a third condition. Okay, so our first condition is two force members to be in equilibrium. Then next condition, three force members to be in equilibrium, and then we study a special case in that. Then we have two forces plus one torque, right? So that is the third condition.